So the next one we talk about is a pair difference. So before we collect two different sample from two different population separately, right? And there's no relationship between sample and sample. But sometimes we do have two population do have relation, right? You can match one sample from one observation from one sample to the other observation to the other sample. Very often, we this is an experiment, right? Sometimes we have a observation before experiment and observation after experiment. So these two are well connected, right? So then we want to see in medicine, medical treatment, right? Rather they say before taking the medicine what you have and taking the medicine after medicine what you have, right? Or cosmetics or any other drugs or treatment after treatment and before treatment, right? So we want to see whether the treatment is useful, is to see the difference is positive, negative, or equal to some number, right? So A, mu D, right? Mu 1 minus mu 2 is mu A, the difference, right? So with one sample is x1 and x2, right? Each observation I, so it's di is the difference between each observation, right? And the mean of the difference is sum of the di over n is called x bar 1, x bar 2 will be, you take the sample difference, right? And the test statistic will be d bar, right, minus mu d, right, over s of d over root n, right? S of d is the sample standard deviation of d, right? So d, right, and tn will be tn minus 1, right? So there's nothing but because of because now the observation is just d, right? It's di, so that's why we don't know the variance, right? So that's why it's sent as a like the one sample d, one sample t test on d. Okay, so this is SD, it's nothing but just the standard sample variance on d, and the two-tailed test, right, with two-sided, right, is n minus 1 because sample is n. So the confidence interval again is d bar and plus minus, right, SD over root n, so it is a standard. Now a medicine test, control group and treatment group, right? Sample size 16, sample mean d equal to 1 and SD is 2, right? And we have mu 1 equal to mu 2, right? But the treatment is not useful, right? The medicine is not useful, so it's 1 minus negative minus 2, right? 2 is root 16, negative 2. So the t table will tell you t n is 15, right? 0.5 is 2.134, and the absolute value of this statistic is less than this critical value, so we can't reject. The p-value is 2 times t bigger than 2.6, then we can't reject. Okay.